Welcome to AutoSense, the world's leading community for ADAS and autonomous vehicle technology development. We create best-in-class events, training, and information to connect the global community of scientists, engineers, and other automotive industry experts. One such expert joining us now is Amir Barniv, Vice President of Strategic Marketing in the Automotive Ethernet Solutions business at Infineon. And Amir, welcome back to AutoSense. Good to see you again, my friend.
Great, Carl. Great to see you again, and really looking forward for another great event of AutoSense.
Yeah, absolutely. And let's start with vehicle architectures. So, how are vehicle architectures evolving? And then, what are the main architecture changes in the vehicle that are supporting the integration of high-speed sensors over Ethernet?
Okay, so Ethernet in the car in general, and especially in the backbone, is become de facto now. Okay, you see that the number of cars that adopting Ethernet and the number of ports of Ethernet per car is growing year to year, probably more than 20% year to year, and that's what we expected. So Ethernet bring many advantages that were not exist before for the in-vehicle network. But I think the biggest transition that really affects the adoption of Ethernet in the car is the transition to zonal architecture. Okay, and I would like to spend a few minutes just talking about this one. The main trigger originally for the transition to zonal architecture was the cable harness inside the car. So the cars of today are mainly what's called domain architecture, where we have a few domains like ADAS, infotainment, body, and each domain has its own controller, and all its agents around the car are connected to this central control of the domain. With different type of networks, okay? And what it means is that you have many cables running back and forth in the car to connect all those agents to their central processors. OEM already identified that that's a big issue. It's the cost of the cable, the weight of the cable in the car, and this is when the industry decided a few years ago to move to zonal architecture, where we are basically splitting the car to geographical zones. In each zone, we have Ethernet switch that aggregate the traffic from all the different agents of the different domain. And then the connectivity inside between those switches inside the network is done with a thin, high-speed Ethernet cable. So the whole backbone is based on Ethernet, which enable to use, less cables in the car and reduce again the weight, reduce the cost, and this is really the advantage of zonal architecture. But OEM realized very quickly that zonal architecture has other advantages that they didn't even think originally. Okay, and the first that now everything is based on a standard solution, Ethernet, which is IEEE based standard. It has the security that is part of Ethernet, the scalability, the intelligence that now enable, instead of have multiple controller in the car, to have one central compute that can control all the different domains in the car. Okay, so this is the process that we see in the car right now, and high-speed sensors will soon become part of this Ethernet network in order to make, the whole proposal of Ethernet end-to-end.
And with that incredible perspective there, Amir, thank you for that. A good history, good context, and good benefits as you're describing for the industry. So taking all of what you've just said, what has been the trajectory then of Ethernet adoption across the automotive industry, and where does it stand right now today?
Okay, great question. So if you look on the cars, we usually drive it or divide it until 2015, then 2015 to 25, and then what's going on beyond, from this year. Until 2015, the car was what we call device-centric. So you had different devices in the car, like GPS, like the radio, the CD, and everything has its own controller. There was almost no network inside the car. Okay, so really you had, as a matter of fact, you had one Ethernet port, and that was for onboard diagnostic. And the speed was relatively low, up to 100 megabit per second. Starting in 2015, the industry moved in what I explained before, the domain architecture. This is what we have today in the cars, where we have different domains, like the ADAS infotainment. Each one has its own controller. And now you see that many of those domains are based on Ethernet. So now you start to see something like 20 different Ethernet ports inside the car. And the speed is also going up. It's going up to 1 gigabit per second. But moving forward, I would say in the next few years, what you will see is that the cars are moving to what we call data and software centric, where we are using the zonal architecture that I just described. And because it's zonal, now you have many Ethernet ports and Ethernet switches. So you have something like up to 70 Ethernet ports in the car. And also the speed is growing up to 10 gigabit per second. And this whole idea of software and the data and software centric car is also related to the new mega trend that called software defined vehicle that we are all hear about. You know, it's a big buzzword that now been used by all OEM, SDV, software defined vehicle. And this is part of the capability to enhance the future car, to do more things that they cannot do today, like download new application, etc.
And you said it, SDV, software defined vehicle. That is the one term that's at the top of our automotive lexicon today. So, Amir, in what ways then does this shift towards SDV? How does that influence the adoption of Ethernet for sensor connectivity?
Okay, excellent question. So maybe we'll start to describe first what does SDV mean for the system architecture. Okay, so the whole promise of SDV is to build a car that can over time download new applications that were not exist when you bought the car, pretty much like our phone, okay, that you can build and add more application and more capabilities. And that means that in order to do it, you need to have enough versatility, okay, with the processing, storage, and networking capabilities inside the car in order to handle the new applications. Okay, very similar to what you have today, by the way, in data centers, but obviously at a different scale. Now, what does it mean for us, you know, as the system provider, the network provider in the car to support it? Basically, I can say it's two attributes that we need to focus on. One of them is flexibility. The other one is security. Okay, so flexibility means that with over time, when we download new application, we can also reroute, or what we call reshape, the traffic inside the car to better serve the new application. Okay, so for example, if we're talking on sensor, if you have some cameras that are connected to one device, now with the new application, you want to change the configuration and connect maybe different camera or additional camera to this device. This can be done very easily with Ethernet. The other aspect, of course, of software-defined vehicle that everyone has a concern with and they're working toward this is security. Okay, now that you can download new software and new firmware for the switches, for the CPU, you want to prevent download of malicious software, and then you need to build the security at many levels inside the design, starting with the network itself, how to validate the software and the firmware before you upload it into the switches or into the CPU. So this is all, again, part of all the features that we need to support specifically for the networking inside the car. And Ethernet really provide all these important attributes, okay? Security is a major part of Ethernet. Flexibility, of course, is enabled by Ethernet. And that's a reason that we are working with OEM on the concept of Ethernet end-to-end, meaning from the edge of the car, all the devices at the edge of the car to the SoC is going to be Ethernet based. Okay, and that's really the big promise for the future in-vehicle networks.
And when it comes to that Ethernet end to end, Ethernet end-to-end. What are the next developments then for future vehicles?
Okay, a great question. So I think maybe we'll start by understanding the advantages of Ethernet end-to-end in the car, okay, and why OEM are really exciting about it. Okay, so to start with, it's going to reduce the cost, which is obviously always, the number one goals of the OEM, okay? When the entire network is based on Ethernet, okay, it means multiple vendors that are developing the switches, define the bridges, okay, which means competition. It's all based on the same standard, IEEE Ethernet standard. So it makes sure that everything is fully interoperable. And when you have competition, always the price goes down, the way we see it with Ethernet in every other application today. The other advantage of Ethernet is related to software. In the future cars, people are talking on anywhere between 100 million to 200 million line of codes. Okay, this is crazy. And it means that every time you move between different trims of cars, like the high end, mid and low end, or to the next generation car, there is so much testing and validation you need to do with the software. Today, they have different protocols in the car, which make it even harder. But once everything is based on Ethernet, okay, what we call Ethernet end-to-end, the software modification, testing, and approval over, between the different models will be much easier for the OEM. So what it means, I guess, on the next development, what need to happen to your question. So we need to make sure that all the sensors, cameras, radar, LiDAR, are running over Ethernet to the car, and the SoC vendors, okay, that are in the process to adopt Ethernet ports, high-speed Ethernet ports that can basically have the traffic from all type of agents inside the car, including sensors, radars, cameras, high-speed videos. All this will be part of the promise of Ethernet end-to-end in the car.
We've been speaking with Amir Barniv, Vice President of Strategic Marketing in the Automotive Ethernet Solutions business line at Infineon. Amir, thank you for helping us just better make that connection between Ethernet and SDVs. We are looking forward to seeing you in person in Barcelona at AutoSense Europe 2025, October 7th through the 9th. Until then, thank you for being with us virtually, at least anyway.
Thank you, Carl, for another great interview, and looking forward to see you and everyone else. We're going to have our booth there, a big booth that's showing our latest demo of Ethernet with cameras over Ethernet, and we invite everyone to see our demos, and looking forward for this great event.
For more information on Infineon and to find out more about our upcoming events, see the links in the description or visit auto-sense.com. That's auto-sense.com. For more in-depth interviews like this, subscribe to the AutoSense YouTube channel and follow AutoSense on LinkedIn. In Detroit, on behalf of AutoSense, I'm Carl Anthony.